بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 6. Today we want to learn equivalent ratios. Equivalent ratios. What's the meaning of equivalent ratios? Our lesson today, how to find equivalent ratios and rates by using unit rate and equivalent fractions. What's the meaning of equivalent ratios? What's the meaning of equivalent ratios? Can be written as equivalent fractions. Can be written as equivalent fractions like 3 over 5 equal 9 over 15. Why 3 over 5 equal 9 over 15? Because if I multiply the numerator and the denominator by 3, 3 times 3 will be 9 and 5 times 3 will be 15. So 3 over 5 and 9 over 15 have the same value, So the name of this ratio, equivalent ratios. And I can write these fractions with a colon like 3 to 5, 3 over 5, 3 to 5 equal 9 to 15. Equal 9 to 15. Or with words, 3 is to 5 as 9 is to 15. 3 to 5 as 9 is to 15. If two ratios are equivalent, they share the same simplest form. If two rates are equivalent, they share the same unit rate. This is the meaning of equivalent ratios. See with me now this video.
What? Still searching YouTube for math help? Are the videos from 2006 really helping? Aren't you tired of finding videos that aren't getting you anywhere in math class? Try something new now.
Hi, welcome to Math Antics. In this lesson, we're going to learn about ratios. Well, what in the world's a ratio? Well, let's look it up in a math book to find out. It says here that a ratio is a comparison of two numbers by division. Well, that's true, but it's also a little confusing. And it's confusing because most of us think of comparing numbers as trying to decide if a number is greater than, less than, or equal to another number. But with ratios, we're not trying to compare numbers like that. Instead, we're really trying to see how two numbers relate to each other. And so at Math Antics, we like to think of ratios as a relationship between two numbers by division. Okay, but how do you compare or show how two numbers are related by division? Well, to see what the by division part really means, let's look at an example of a ratio. Excuse me, that's not a ratio, that's a fraction. Oh, it's a ratio, all right. Mathematically, ratios and fractions are basically the same thing. It's just that when we use a fraction in a particular way, we call it a ratio. Well, sure, everybody knows that. Well, like I was saying, ratios are basically just like fractions. The difference is how we use them to describe things in the real world. To see what I mean, let's look at examples of how we could use the fraction 1 over 2 and the ratio 1 over 2. Mathematically, these are both the same thing. They're just the division problem, 1 divided by 2. But in the case of the fraction, we usually treat it as if it's just a single number. For example, at lunchtime, you might eat 1 sandwich, or if you're really hungry, you might eat 2 sandwiches. But if you're not very hungry, you might just have half a sandwich. We can use the fraction 1/2, just like we use 1 or 2 to show how many sandwiches you eat. It's just that in the case of 1/2, we know that it's only part of a sandwich, just a fraction of one. Now let's see how we can use the ratio 1 over 2. With a ratio, we don't treat it as if it's just a single number. Instead, we pay close attention to the top and bottom numbers because we use them to refer to different things. For example, let's say we're planning to go on a picnic. And for every 2 people that are going on the picnic, we're only bringing 1 sandwich. In that case, we'd say that the ratio of sandwiches to people is 1 to 2, or 1 sandwich per 2 people. Do you see the difference between our fraction and our ratio? The math part of each of them is the same. But with the fraction, both the top and bottom numbers are referring to the same thing, the sandwich. However, with the ratio, the top and bottom numbers are referring to different things, sandwiches and people. The fraction shows a part of something, but the ratio shows a relationship or a comparison between two different things. And you can see that they're the same thing mathematically, because if you did have the ratio of 1 sandwich for every 2 people on a picnic, guess how much of a sandwich each person would get? Yep, half a sandwich. All right, so now you know that fractions and ratios are basically the same thing. But since they're used differently in math, sometimes they're also shown differently. Once in a while, instead of seeing the standard division form, a ratio might be represented with this symbol. When you see a ratio written this way, it just means 1 to 2 or 1 per 2. For example, in this picture, you could say that the ratio of dogs to cats is 3 to 2. 3 dogs to 2 cats. And you could also write it in the standard division form. 3 dogs over 2 cats. They're just different ways to write the same ratio. Ratios are used all the time to represent all sorts of things in real-world situations. So let's see a few more examples to help you really understand what ratios are. Have you ever wanted to compare apples to oranges, but someone told you couldn't? Well, you can with a ratio. Now let's say a fruit stand sells 5 apples for every 3 oranges they sell. The ratio of apples to oranges would be 5 to 3. Or, have you ever helped someone bake cookies? The recipe might tell you that for every 2 cups of flour, you need 1 cup of sugar. That means that the ratio of flour to sugar is 2 to 1. Or, what about your TV screen or your computer monitor? Have you ever heard someone say that the size or aspect ratio is 16 to 9? 16 to 9 is the ratio of the screen's width to its height. So if the screen is 16 inches wide, then its height would be 9 inches tall. Here's another good ratio that you might use in your car. 40 miles per hour. Aha! Didn't you say that a ratio was a relationship between 2 numbers? But 40 miles per hour is just 1 number. Looks like someone's got some explaining to do. Actually, there are 2 numbers. Do you remember how any number can be written like a fraction just by writing 1 as the bottom number? Well, 40 miles per hour is the ratio 40 miles per 1 hour. Well, I guess you have an answer for everything, don't you? 40 miles per 1 hour is a type of ratio that we call a rate. A rate is just a ratio that usually involves a period of time. Here are some common examples of rates. 10 meters per second, $12 per hour, 3 meals per day, 50 games per year. Notice that the bottom numbers in each of these ratios relate to a period of time. Seconds, hours, days, years. And that's why we call them a rate. All right, so that's simple enough. But you might be wondering, why are the bottom numbers of all these rates 1? Couldn't you have a rate like 90 meters per 9 seconds? Or $60 per 5 hours? We sure could. But most of the time, when we have rates like that, we want to convert them into an equivalent rate that has 1 as the bottom number. And that's because whenever the bottom number represents only 1 unit of time, like 1 hour or 1 day, it makes comparing different rates much easier. For example, imagine 2 cars driving at 2 different rates. The first car's rate is 120 miles per 3 hours, and the second car's rate is 150 miles per 5 hours. Which car is going faster? Well, it's not all that easy to tell when the rates have different bottom numbers. Fortunately, it's really easy to change a rate so that it has 1 as the bottom number. All you have to do is divide the top number by the bottom number. The answer you get is the top number of the new equivalent rate, and the bottom number is just 1. Rates like this are called unit rates because unit means 1. All right, let's convert the rates of speed for our two cars into unit rates so that we can compare them easily. The first car's rate was 120 miles per 3 hours. So if we take 120 and divide it by 3, we get 40. That means that the unit rate for the first car is 40 miles per hour. The second car's rate was 150 miles per 5 hours. So if we divide 150 by 5, we get 30. So the unit rate for the second car is 30 miles per hour. And now you can easily tell that the first car is going faster. And you can tell why unit rates are so helpful. Okay, so that's it for this lesson. We've learned that a ratio is basically just like a fraction. But instead of showing what part of something you have, it shows the relationship between two different things. We also learned that when one of those two things is time, we call the ratio a rate. And last of all, we learned how to convert a rate into a unit rate for easy comparison. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
So this is the meaning of ratios, and what is the difference between ratios and fractions, and what is the meaning of equivalent ratios. See with me this example. Use unit rates to determine equivalent rates. How can you write 20 miles in 5 hours as a fraction? Take 20 miles up using the fraction and 5 hours down. So the ratio will be 20 miles per 5 hours. 20 miles per 5 hours. How can you write 45 miles in 9 hours as a fraction? Now, what is the unit rate for each? Yes?
Mr. Max, we divide the 40. We will divide the 40 with the 9, then we will take the answer, put it up, then we write down 1.
It's clear now? It's clear for all? Okay. Our example now, use unit rate to determine equivalent rates. How can you write 20 miles in 5 hours as a fraction? Write the fraction and take 20 miles, put it up, and take 5 hours, put it down. So now we have 20 miles per 5 hours. 20 miles per 5 hours. Now, how can you write 45 miles in 9 hours as a fraction? The first step, write fraction. Then take 45 miles up. Then 9 hours down. Now we have ratio. We have now ratio. The question now, what is the unit rate for each? 45 mile and 9 mile. So look to the denominator. Denominator here will be 9. So divide up and down by 9. Divide up and down by 9. So divide by 9 and down, divide by 9. So the unit rate will be
Mr. 5/1.
45 divided by 9 will be 5 mile and down 90 hour divide by 9 will be 1 hour. Will be 1 hour. So the unit rate means we have 5 mile per 1 hour. 5 mile per 1 hour. What is the meaning of this unit rate? Means we have 5 mile per 1 hour. Per 1 hour. Are the rate equivalents explained? No, the rates don't have the same unit rate. Don't have the same unit rate. Here, the unit rate here, if I want to find the unit rate here, look. Divide up by 5 and divide down by 5. 20 divided by 5 will be 4. 9. And 5 divided by 5 will be 1 hour. Compare now. Is it 4 mile per 1 hour equal 5 mile per 1 hour? No. The rate's different now. So we don't have equivalent. We don't have equivalent because we have different unit rates. How could you adjust one of the rates so that the pair of rates would be equivalent? The simple answer here, the second rate could be 36 mile in 9 hours. 36 mile in 9 hours. If I want to write the simplest form here, the unit rate will be 4 mile per 1 hour. Per 1 hour. Now compare. As you see now, the first unit rate 4 mile per 1 hour, and the third unit rate 4 mile per 1 hour. So the same value means 20 mile per 5 hour equal 36 mile per 9 hours. So I can write and I can say 20 mile per 5 hour equivalent with 36 mile in 9 hours because the two unit rates or the two ratios here equal the same value. The second example here, we have this table. The first column, with the first row, we have cans of juice, and the second row we have cans of water. Here we have three ratios: 1/3, 2/6, 3/9. How to know if I have equivalent ratios or not? Choose any two ratios. I can choose 1/3, and for example, I can choose 2/6, 2/6. 2/6, if I do simplest form, 2/6, divide by 2 up and divide by 2 down, 2 divided by 2 will be 1, and 6 divided by 2 will be 3. That means 1/3 and 2/6 has the same value, equal. So 1/3 and 2/6 equivalent ratios. So this is our lesson today. What's the meaning of equivalent ratios? Who has a question now? What is the name of our lesson today?
Equivalent ratio.
Ratios.
Equivalent ratio.
What's the meaning of equivalent ratios? What's the meaning of equivalent ratios? What is the meaning of equivalent ratios? The ratios who have the same value. The ratios
Same
who have
value.
the same value.
The
This is
same
the meaning
value.
of equivalent fraction or of equivalent ratios. Now I want to from all to prepare your notebook or any paper and work with me, please. The question now determines if each pair of ratios or rates are equivalent. Explain your reasoning. But so the question now determine if each pair of ratios or rate are equivalent. The third sentence, we have $18 for 3 bracelets and $30 for 3. The first step, take the first part of this sentence and write this rate. Write this rate. So write fraction. We have here 18 dollar, and down we have 3. Now write the unit rate. Write the unit rate. How to write the unit rate? Look to the denominator. Look to the denominator. The denominator will be 3. So divide up and down by 3. Divide up and down by 3. 18 divide by 3 will be 6. And 3 divided by 3 will be 1. So the unit rate here will be 6 over 1. Will be 6 over 1. Take the second part of this sentence and find the ratio. Right, the ratio. We have $30 for 5 parcels. So write fraction. Then $30 up. Then 5 down. Then
Divide by 5.
find the unit rate. Great. Find the unit rate. Divide by 5 up. 30 divide by 5 will be 6.
6 over 1.
5 divided by 5 will be 1. As you see here, compare between the first rate and the second rate, you find the same unit rate. You find here the same unit rate. You have the same unit rate. As you see here, we have the same unit rate. We have the same unit rate. That means this is equivalent or not equivalent? Equivalent. Because they have the same unit rate. They have the same unit rate. So the two ratios here will be equivalent. Will be equivalent. Do you have any question now here? Do you have any?
I don't have a question.
It's clear for all.
مو واضح.
Let's go to the next sentence. Now the sentence, we have 120 calories in 2 servings and 360 calories in 6 servings. I want to from all now to tell me, is it the two ratios here equivalent or not? You have 3 minutes to work. Start please.
Mister, I finished.
Yes, it's equivalent or not?
Yes,
Yes, Mr. It's equivalent.
yes.
Okay. Who has another?
Yes,
answer?
Mister.
Who has another answer?
Equivalent.
Equivalent.
Mr. I solved it now. It is equivalent.
But let us to check together. Take the first part of this sentence. We have 120 calories.
3/1.
So write a fraction, write up 120 calories down to serving. Then try to find the unit rate. Look to the denominator. Denominator will be 2. So divide up and down by 2. 120 divided by 2 will be 60. Down. 2 divided by 2 will be 1 serving. Now go to the next part of this sentence. We have 360 calories over 6 serving. Now try to find the unit rate. Look to the denominator here will be have 6. Now divide up and down by 6. 360
6.
will be also 60 calories, and 6 divided by 6 will be 1. So as you see here, we have the same unit rate. We have the same unit rate. So that means the rates here will be equivalent. The rates here will be equivalent. Why equivalent? Because they have the same unit rate. They have the same unit rate. So this is equivalent. This is equivalent. Okay. Go to the third question. The question now, we have 4 hours work for $12 and 7 hours work for $28. I want from all to check, is it the two ratios here equivalent or not? You have 3 minutes. Start.
Mr. This,
Yes.
Mr. I solved this question and I found it's not equivalent.
Not equivalent. Thank you. Who else? Who has another answer?
Mister, I finished and it's not equivalent.
Not equivalent. Thank you. Who has another answer?
Not equivalent.
Not equivalent. طيب. Let us to check together. Take the first part of this sentence. 4 hours up and $12 down. Then try to find the unit rate. We have down 12. So divide up and down by 12. Divide up and down by 12. So up here we can write 4 divided by 12, and down we can write 12 divided by 12. 12 divided by 12 will be $1. And 4 divided by 12, we have here fraction, or I can write it as a decimal. I can use the decimal here, or I can write it as a fraction, no problem. So 4 divided by 12 will be nearestly 0.4. Nearestly will be 0.4. And here we have 7 and down 7 hours, and down we have $28. Now try to find the unit rate. $28 divided by 28 will be $1. Try to find 7 divided by 28. We can write it as a fraction and we can write it as a decimal. 7 divided by 28, nearestly 0.25. 0.25 hour. So compare now. Is it the two unit rate same or different? As you see here, 0.4 year 1, and here 0.25 year 1. So not equivalent. Not equivalent. Why? Because we have the different. Because we have the different ratios. We have the different unit rate. We have the different unit rate. Right. Who has a question now here? Is it clear for all? Is it clear?
Yes, Mr.
Yes.
No questions? Okay. Right. Now we have 15 blank CDs for $5 and 45 blank CDs for $15. I want from all to check. Is it the two ratios here equivalent or not? Start.
Equivalent.
What's your name?
Daniel.
Okay, thank you, Daniel. Who has else?
Yeah, it's equivalent.
What's your name?
عمر أشرف.
Omar Ashraf. Thank you, Omar. Who has else?
Mr. Equivalent.
What's your name?
Mr. Khalid.
Okay, thank you, Khalid. Who has else? Who has another answer?
Equivalent.
Equivalent. Let us to check together. Now we have 15 plan over $5. Try to find the unit rate. Divide up and down by 5 because the denominator here will be 5. So 15 divided by 5 will be 3. Divide by 5 will be 1. Then take the next ratio. We have 45 plan over $15. So find the unit rate now. Divide by 15. Up and down. Divide by 15. 45 divided by 15 will be 3. Divide by 15 will be $1. So as you see, we have the same unit rate. That means the ratios here will be what? Will be equivalent. The ratios will be equivalent. So this is our lesson today. Who has any question now?
No, I don't have.
No questions?
No question, Mr. No.
It's clear for all?
Yeah.
Really? So what is the name of our lesson today?
Ratio equivalent.
Equivalent ratio.
Equivalent ratios. What is the meaning of equivalent ratios?
The same.
The same value.
Great.
The same value.
The ratios who have the same values. طيب, let us take attendance now. فضي here. عارف محمد علي.
نعم أستاذ.
حمدان الكعبي.
هلا أستاذ.
خالد خليل here. دانيال.
سلطان.
سعيد محمد. سعيد محمد. سلطان علي.
مستر أقدر أطلع؟
اللي طلع اسمه بيطلع. سلطان علي.
نعم أستاذ.
سلطان غازي.
نعم أستاذ.
عامر.
نعم أستاذ.
عبد الله الحمادي.
نعم أستاذ.
راسم.
نعم.
عبد الله الجابري.
نعم أستاذ.
عبد الله مسعود. عبد الله مسعود. عبد الله مسعود. عمير الشامسي. عمر أشرف هير. فلاح.
نعم.
محمد الحمادي. محمد سعيد السريحي.
نعم.
محمد حمادة.
نعم.
محمد سهيل. محمد سهيل. طاوع هير.
نعم أستاذ.
عاصر. منصور علي.
Here. أنا أستاذ.
Great. So this is our lesson today. Thank you for your listening. Have a nice day. See you tomorrow inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.